Hey everyone, so this is chapter 2 of documenting my Kubernetes learning journey. In the previous chapter, we saw a very high level overview about Kubernetes architecture and different type of component it has, such as API server, controller manager, CCM, scheduler, etc., Kubelet and all that stuff, right? And we also saw what each of the component does. So in this chapter, we are going to run a kubectl command. Kubectl is basically a command line tool using which you can run Kubernetes API via command line and do changes in your Kubernetes cluster. So we are just going to run one kubectl command which brings up one pod, and we are also going to see what happens behind the scene, like in the process of triggering that command and the getting the pod up. In the process, which components are talking to each other in Kubernetes architecture. So that we are going to see in this chapter. All right, so let's start. So now to start with, what we will do is we will just try to run kubectl command to create a pod in our Kubernetes cluster. And once the pod gets created practically, and then we will see what are the things happening behind the commands, right? How the pod got created. So for that, if you're trying to follow me, then you need to have a local Kubernetes setup. For that, you will either need kind or minikube setup on your machine. So I have a minikube setup done, and if I just go here, like you can see minikube, it is a single node cluster and it's running kubelet. These are the components of your Kubernetes. Okay, so the command that we are going to use is kubectl apply -f. I have a pod.yml file in here. Okay, let me just copy this command. And okay, so we will just try to run this command and see what happens. So what is this pod.yml file, right? So this is the YAML configuration of the pod, like which container, which image it will use, what will the container name. So ignore this for now, keep this as extra abstraction, and in future chapters we will try to cover this in detail. So for now, just assume this creates a pod in your Kubernetes cluster. Okay, so this is the YAML file that we are passing to that command. Okay, so let me now just run this command. Okay, you can see the pod, this pod got created, demo pod aman, right? This is the pod name that we gave in our YAML file, this return demo pod aman. So it got created. Just for confirmation, we'll just see kubectl get pods. We can see our pod got created, and which is just 18 seconds ago. Okay, now now what happens behind the scene? How did this got created, right? This is the main question in here. So let's go to our diagram back. So this is the command that we ran on our command prompt. So what happens is kubectl will talk with API server via REST APIs. So this is the first step, and this will talk via REST APIs. It will tell API server, hey API server, user wants to create a new pod in our cluster. Just facilitate it. Okay. So now what API server will do is API server will validate the pod's specifications, whether it's valid or invalid, and then once it's validated, then it will just store the pod's data inside this etcd. So if you remember the previous chapter, etcd is basically the database of your cluster. Whatever things are going on in the cluster are all stored in etcd, and the only person who is able to access etcd is your API server, right? And every other component talks, if every other component wants to fetch some data from etcd, it talks with API server, and API server gives them the data needed. Okay, so back to our topic. Kubectl will talk with API server. Hey API server, I have a request for a new pod. API server will validate the pod specification and store the data in etcd. Now scheduler will sync with API server to check if there is any new pod to be scheduled. Now API server will again sync with etcd. This will be fourth point. It will API server will sync with etcd to check if there are any unassigned pod, right? So since it got the unassigned pod now, so API server will go back to the scheduler and say, oh hey scheduler, there is one unassigned pod, right? So scheduler will do its job now. Scheduler will what scheduler will do is it will check the worker nodes. Since there are multiple nodes in here, so it will check, okay, this, I think the node number 2 has some less load, so let me assign the new pod to worker node 2. So now if you remember, Kubelet is the guy who's responsible for handling pods in its node, right? Pod related stuff. So scheduler will not directly talk with kubelet. Hey kubelet, in worker node 2, there is an unassigned pod. I am assigning it to your node. Just handle it. It won't happen this way. What scheduler will do is in etcd, there will be a pod object, right? This pod will have a pod object, and inside the pod object, etcd will just update the node name. Uh, for example, it will be something like this: node name equals to, and it will be node 2. So scheduler will assign it to node 2. Now, since this got assigned, now kubelet will sync with API server. Hey API server, is there any unassigned pod that got assigned to my worker node? Is there something? API server will again check with etcd. Hey, okay, hey, scheduler have assigned one pod to your node. Just handle it. Then Cube API server will let it know that hey, there is a unassigned pod to your worker node. Just handle it. Then what happens is kubelet will, if I just do this, now what happens is kubelet knows that okay, there is one unassigned pod that I need to handle in my worker node. So as we know, kubelet don't directly runs the pod, right? It needs container runtime to run through it. So kubelet will talk to container runtime, and this won't happen directly, right? As we remember, this happened via container runtime interface. So kubelet will talk to container runtime via container runtime interface to run a pod, and then this will run your pod. Run your demo pod command in worker node 2. Okay, so this is a very high level overview of what happens behind the scene if you just run, if you just try to create a new pod in Kubernetes, like how different component talks to each other. So if you see, if we create it, it just happens in a blink of a second, but these are all the stuff going on in background, right? So this was it about chapter 2, about what happens in the background. And in the future chapters we will see about pods, deployment, services. Okay, thank you. Bye.